So hi guys, my name is Rishesh Sharma and today I will provide a topic that is assembly language programming, a comprehensive guide. In this we will discuss about the assembly language programming with Intel 8085 and 8086 microprocessors. So in this we will discuss what is assembly language programming and how to unleash its power. Then we will discuss into the architecture of 8085 and 8086 microprocessors. And finally, we will wrap up with a conclusion that summarizes what we have learned and provides some next step for further explorations. So without wasting time, let's start. Before going into depth, we should know about machine language and assembly language and its programming tools. So assembly language is a human readable and mnemonic representation of a machine code and instructions. It uses symbols and mnemonic representations. It individuals operations, registers, memory addresses and other elements of the computer architectures. For advantages, we can discuss assembly language provides a more readable and understandable format compared to machine language. It makes easier to programmers to write and maintain code. It also direct access to the hardware resources, providing fine-grained control over the system. Intel 8085 microprocessor architectures has 8-bit register file consisting of 6 general purpose registers and 2 8-bit internal registers and various specific purpose registers. It has a 16 bus address and can access a total of 64 KB memory. While in 8086 microprocessor, it is a 16-bit processor, meaning that it can process data in 16-bit chunks. And it also segment memory management, which allow for efficient management of memory and better resource utilization. Now moving further, the registers and memory are the essential component of assembly language programming. Registers provide temporary storage within the processor while the memory serves as the primary storage medium. By effectively utilizing registers and managing memory, programmers can develop efficient and powerful assembly language programs. The instruction set architecture refers to the set of instructions that computer process and execute. It includes key aspects and components of instruction set architectures are instruction type, instruction encoding, registers, memory models, interrupt and exceptionals, privileges, and extensive variants. Some examples are it includes exit, ARMs, MIPS, and RISC-V. Each of it have a unique instruction set, encoding formats, and architectural features. In writing and debugging the assembly code, you should understand the instruction set architecture of a target processors and understood the availability of instruction, their format, registers, register usages, and addressing modes, and memory optimization. Then you should plan and design about how to write the code and start by setting up the necessary data and registers. Write the code in small manageable sections and focus on one task at a one time. Test and verify that your code is running well and then debug it if it has any error. Then analyze your error and exceptions. Finally, make increment changes and use diagnostic output, learn the examples and seek to help it. Remember that writing and debugging assembly code requires patience, attention to details, and go through understanding of the target processor architecture. Practice experimentations and learning from the experience are key to becoming proficient in assembly programming. Some real-world applications are manufacturing, medical devices and equipment, and many more. While assembly language programming may not be the primary programming language used in modern software development, it offers a unique benefit for improving your programming skills. It enhances your understanding of computer architectures, boosts your programming solving abilities, and enables you to write efficient optimization code in a language. Thus, we can say that assembly language can help us to improve our programming skills. To write an assembly language program, you should define the program, that what is the problem and what is it asking for. Then you should choose the assembly language platform, in which platform you want to do work, such as x86, ARM, MIPS and other architectures. Break down the problem into smaller subtasks or functions. Then begin your writing code. Focus on one task at a one time. Then test and debug your code, optimize the performance and documentation. Maintainability, readability should be right and clean, well structured and easy to understand or maintain. Use meaningful variables, labels, follow consistent identities and formatting practices and to coding standards. There are several tools available to write the assembly language programming. It provides features such as assemblers, debuggers, simulators, and integrated development environment that are called as IDEs. To choose a tool based on your specific assembly language and target the platform. The availability and compatibility of the tools may vary depending on the architecture and development environment you are working with. Consult the documentations and resources specific to your chosen assembly language and platform to find the most suitable tools for your programming needs. And for writing codes, you can see some examples that may include add B, subtract C, etc. Here is an example of assembly language code written for X8 architecture using Intel syntax. This code can calculate the factorial of a given number using a recursive function. As you can see in this example, the program prompts the user to enter a number, reads the input, and then calculate the factorial of a given number using a recursive function. The result is then printed to the console. Please note that assembly code can vary based on the specific assembly language architecture and development environment being used. The example provided above is the X8 architecture using Intel syntax and Linux system calls. For advanced data and techniques in assembly language, build upon the foundational knowledge of basic assembly language. I can provide some conceptual techniques that you can explore in assembly programming. The first of all is advanced data structure. Implementing the complex data structure in assembly language can enhance your understanding of memorizing and management of data opportunities. It may include linked list, binary trees, hash tables, and graph, and many more. Other than this, you should also know about single instruction and multiple data, that is known as SIMD. Its instruction, it enables the parallel processing by the instruction. Multi-threading and parallel programming. Assembly language can be used to develop multi-threads or parallel program. Understanding and synchronization of mechanism, atomic operations, and memory barriers enables efficient use of multiple cores and threads. These advanced concepts and techniques require a strong foundation in assembly language programming and a deep understanding of target architecture. Learned through practice experimentations and studying advanced assembly programming resources will help you expand your skills, and definitely it will become proficient in these areas. Some real-world examples of assembly language programming are embedded systems, operating system development, graphic programming, game development, reverse engineering and security research, real-time latency systems, cryptography and encryptions, high performance computing, and many more. A real-world example of assembly language programming can be found in development of device drivers. Writing a device driver often involves the programming in assembly language to direct access and manipulate the hardware registers and interface the specific devices. As you can see the code that is shown on your screen. In this example, the assembly code represents a device driver for a computer network interface card. The code initializes the NIC hardware, setup interrupts handlers, and start the NIC for packet transmissions and receptions, continuously process information packets, and finally shut down the NIC property. This example demonstrates how assembly language programming is used to directly interact with the hardware registers and interface of a specific device to implement low-level functionality required by the device driver. I hope you understand my all explanation. And now time for a conclusion. So in the end, I will only want to say that assembly language programming is essential. Mastering the assembly language programming with Intel 8085 and 8086 microprocessor is essential for aspiring computer engineers, as it allows for a direct control of computer behavior and unlocks new possibility for framework and hardware development. With the assembly language programming, the potential is limitless. Assembly language programming opens a door to a wide range of opportunities. It is the core of operating system development, device drivers, real-time system, embedded system, and many more. By mastering assembly language, we can gain ability to tackle complex challenges, optimize the critical code sections, and build system that pushes the boundaries of performance and efficiency. I would encourage all you to explore assembly language programming further. dive into the world of mnemonics, registers, bitwise operators, and other embeddings. By doing so, we will unlock new levels of control, depend on understanding of computer system, and become a more versatile and skilled programmer. Thank you for your time and attention. Keep pushing the boundaries of technology and may your journey into a assembling language programming be a regaining and enlightened. Thank you for watching these videos. Thank you for watching this whole presentation. I hope you liked this presentation. If you like, then please like and subscribe.